Hello and welcome to section 8.2. Here are the solutions for 8.1. Most of the time the book doesn't use expanded form like I do, so you're going to see them use techniques a little bit different than me. I of course think that expanded form is a little bit better and it's less work. You don't have to really memorize much. So keep that in mind when you're checking over these answers. Today we're going to learn about a couple new methods with exponents, except for we're going to be working with division. Before we get to that, I want to solve this question here and just kind of show you guys something so that you don't make a mistake later on. I'm going to expand out the 4x times 4x, and then I just wanted to remind you guys that if the exponents aren't the same on your variables, you cannot combine them. It's just like, it's called combining like terms. Just like if you have like an x and y, you can't put them together. So keep in mind that your final answer would be this guy right here. Okay, let's get into exponents with quotients or division. We're going to be learning some new techniques today. And again, I'm going to focus on more expanded form. Okay, so the first one, what I'm going to do is I'm just going to write this out. I'm actually going to change this question to positive 3 and positive 3. We have 3 times itself 9 times. And then we have 3 times itself 3 times. So for every 3 divided by 3 I have, this is 1. And so like when I do this, I'm not actually canceling them out. I'm just saying that this is equal to 1, and this is equal to 1, and this is equal to 1. So keep that in mind. You're not canceling anything out. You're coming up with factors of 1 or dividing to 1. So we're basically reducing these here. All right, so I have 5 times 5 times 5 times 5, and then I have 8 more 5s. That's a lot of 5s. There's 12 of them. And then on the bottom I have 5 times itself 7 times. And then I'm going to see how many of these will equal 1. So that equals 1 and that equals 1. Those all equal 1. And I'm left with 5 to the 5th power. Okay. And then I didn't leave myself a lot of room. I have 1 over x to the 4th times x to the 6th. What I'm going to do is I'm going to put this as a fraction so I know we have x to the 6th on the top and we have x to the 4th on the bottom. I'm just multiplying fractions there. And then I can expand. I have x times itself 6 times, and then x times itself 4 times. That's 1. Those are all 1, and I have x times itself 2 times. Okay, nothing different here, except for the mistake that students make is they don't just simply reduce the fraction. 1, 2, 3, 4, 5, 6, 7. So these we know equal 1. I have x to the 5th, but what about my 10 divided by 2? 10 divided by 2, just treat that as a normal fraction. It's 5 divided by 1, or just simply 5. So don't try to make things complicated with the numbers. So this one here, I have 6 over 30, which is 1 over 5. Now the 5 is on the bottom, so I'm going to put the 5 on the bottom right away. And then p times itself 8 times. And then p times itself 3 times. So we're going to reduce all those to 1. So I have p to the 5th on the top over 5 on the bottom. You don't need to put the 1 there. If there was nothing left on the top, you'd want to make sure there was a 1 there. All right, here we have a whole bunch of variables. 18 divided by 4 reduces to 9 over 2. So I'm just reducing my fraction first, 9 over 2. And then I'm going to expand out my x's, my y's, and my z's. I have 5 x's, I have 3 y's, 4 z's. And then I'm going to reduce to 1. Those all reduce to 1. That y. And then 2 pairs of z's. Okay, so let's write our final answer now. I have 9 divided by 2, and then I have x squared, y squared, z squared. Oh, okay, and nothing. The only thing that's on the bottom is my 2. Could you write 4.5? I suppose you could, but Fraction form is okay. Now here we have fractions, and we're raising them to a power. You're going to treat this just like anything else. You're just going to write out that number 4 times. It's 2/3 times 2/3 times 2/3 times 2/3. So 2 to the 4th over 3 to the 4th. Here I have 2x over y times y, and I'm going to do that 4 times. So notice how I expanded this to y times y. Expand what's inside the parentheses first. That'll make your work a little bit easier. Okay, so I have 2x over y times y 4 times. So 2 times 2 times 2 times 2 times 2 is 16. And then x to the 4th over y to the 8th. Let's see, anything new here? Nothing new there. So nothing too... I'll do this one. There's 2 fractions here. We'll take a look at this one. This is a times a. So I have a over b 5 times. And then I have 1 over 2a times a. So here I have those reduced with those. Those equal 1. So I have a times itself 8 times. And on the bottom, I'm going to put my 2 first, my numerical value first, and then b times itself 5 times. So there you go. And then this one is a good one. I like this one. 2s over 3t, 2s over 3t, 2s over 3t, and then t times t times t times t times t over 16. Okay, let's simplify up here. I notice that 2 times 2 times 2 is 8. So if I put multiply my 2's together, that gives me 8. That's going to reduce with the 16. So I'm going to simplify that up there. And then I have t and t and t on the bottom with the t and t and t on the top. So on the top part, I have s cubed times t squared. And on the bottom, I have 3 times 3 times 3, which is 27. Oh, and then I have times 2. So sorry, that should be 54. 54 on the bottom. So let's say you did 2 times 2 times 2 times 2, and you did 8 on the top. And then you did 3 times 3 times 3, which is 27. 27 times 16. You're just going to have to, this is going to be a large number. You're just going to have to reduce, simplify and reduce. This eventually will give you 1/54th, which is what we have here, 1/54th. So I just decided to reduce before I multiplied everything together, just to make my numbers a little bit smaller. And then here's your assignment. 39 and 41 will be challenge questions. They're similar to the challenge questions on the last section. They're worth a try. So thank you guys for tuning in to 8.2.